Hi, everyone. So this lesson, 7.3, is on similar triangles. I like to call it similarity shortcuts because there are three theorems that we're going to learn that are sort of like shortcuts in determining if triangles are similar. Now, these theorems only work with triangles. They don't work with like a four-sided figure. So it's important to remember that. So there are three of them. They're kind of similar to the ones we did in chapter 4. If you remember, for triangle congruency, we had like side, angle, side, 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 angle, side, angle, and angle, angle, side. So some of those apply with similarity, but not all of them. So the first one that we have for similar triangles is called angle, angle similarity. So that's this first one here. And it says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So if you see in this picture here, see how angle A and angle D are congruent, angle B and angle E are congruent. So that would be enough to say the triangles are similar. In our last section, no matter what, we always had to set up ratios of the corresponding sides to see if they're proportional. But with triangles, you only have to know that the angles are congruent. So if you look at this example here, let's determine if these two triangles are similar. So I see that they have angle S is congruent to angle R. So that's one pair of congruent sides. But notice that 60 and 30 are not the same. So you may be tempted to say that no, these are not similar. However, you can find this third angle, M and T, because the angles add to 180, and then compare. So I'll find angle T first. If you add 30 and 90, that's 120. Subtract from 180 and you get 60. Same thing over here. 150 from 180 would be 30. So see how now that I found those missing angles, now they do actually match. So I would say that yes, these triangles are similar. And we say it's by angle, angle, similarity. It also asks us to write a similarity statement. So remember, for similarity statements, you pick the order for the first one. So I'm going to say MSK is similar to QRT would be the matching order. Okay, so that's angle, angle similarity. The next theorem is called side, side, side similarity. And it says if the measures of corresponding sides of two triangles are proportional, then the triangles are similar. So for this one, you don't need to know any angles. You just need to know the sides, all three sides of both triangles. And you have to set up ratios of those corresponding sides, divide them to see if they're equal. Now, when you're matching up the sides with an example like this, we don't have the angles given to us. So you have to make sure you're matching them up properly. For something like this example, it's kind of easy because they're facing the same way. But as a rule of thumb, the biggest one in one triangle will match with the biggest one in the other triangle. So 15 would go with 10. The next biggest one in DEF was 12. So that would go with the next biggest one in BC, which is 8. And then lastly, 9 would go with 6, the two smallest ones. So we're asking ourselves, are these ratios equal? Well, 15 over 10, I can divide top and bottom by 5, and I get 3 over 2. 12 and 8, I can divide by 4, and again, I get 3 over 2. 9 and 6, I can divide by 3, and I get 3 over 2. So we would say that, yes, these triangles are similar, and it would be by side, side, side similarity. So I'm going to say yes. Triangles are similar by side, side, side similarity. And then we need a similarity statement. So I'm going to do ABC is similar to triangle DEF. So that's side, side, side. The last theorem is called side, angle, side. And it says if the measures of two sides of a triangle are proportional to the measures of two corresponding sides of another triangle, and the included angles are congruent then the triangles are similar. So we have to remember what we mean by included angles. Remember, included angles are, if I have this side and this side, the included angle is where they touch. So angle A here. If I have this side and this side, included angle is where they touch. So here. So it has to be the included angle. It couldn't be like one off to the side like that. It has to be where the two marked sides touch. So see how I'm still at school recording this video, if you can't tell. Anyway, so see how this one, we have this side with an included angle, this side with an included angle. So these angles are congruent, which is what we need. Just because we're given side, an angle and a side for both of the triangles doesn't mean they're similar. You have to test it out. So see how 10 would go with 15, and then 14 would go with 21. So you want to set that up and reduce them. 10 over 15 would be 2/3 because they're divisible by 5. 14 and 21 also 2/3, divisible by 7. So I have two pairs of proportional sides and a pair of congruent included angles. So I'm going to say that yes, the triangles are similar by side, angle, side this time. And so for a similarity statement, we can do triangle TSU is similar to triangle PJM. So that's side, angle, side. So we have angle, angle, side, angle, side, and side, side, side. So this is what the practice problems look like. You have to determine if they're similar. If so, write a similarity statement and state which theorem would be used. So let's do the first one. The first one, we're only given sides. So the only possible shortcut would be side, side, side. But we can't just say automatically, yes, similar by side, side, side. We have to actually test it out. So we need to set up ratios of the corresponding sides. So 32 would go with 20. Is that equal to 24 over 15? Whoops, I accidentally wrote 15 on the top. Don't do that. I went big to small, so now I have to go big to small for all of them. And is that equal to 40 over 25? So you can either divide these or you can simplify them. I'm going to simplify them underneath here because I kind of ran out of room. 32 and 20 are both divisible by 4, so that would be 8/5. 24 and 15 are both divisible by 3, so also 8/5. And 40 and 25 both divisible by 5, also 8/5. So we're going to say yes, they're similar by side, side, side similarity. And then it's GHI is similar to triangle QRS. Okay, so there's letter A. The next one, 36 and 20, and then we have 24 and 18. We have a pair of congruent angles. So this one could possibly be side, angle, side. We don't know. We have to check. So the 36 is the bigger one. So that's going to go with 24. And then 20 is going to go with 18. So are they equal? Let's see. 36 and 24 are both divisible by 6. So that's going to be 6 over 4. Oh, they're both divisible by 12. So 12 is the highest one. So that's going to be 3 over 2. 20 over 18 are both divisible by 2. So we have 10 over 9. Those are both in simplest form. They're not equal. So these are not similar. You don't fill in the by, you don't fill in the statement. Another way that you could do it is if you only have two sides that you're comparing, you can just cross multiply them. That only works if you have two of them though. So if you wanted to do that for this one, we would have, let's see, 36 times, oops. So we could do 36 times 18, which is 648. And if that's equal to 24 times 20, which is 480. So see how those aren't equal? So that would be another option. That only works if you have two of them though. You can cross multiply them. Okay, so that one was a no. And then letter C, it's actually no work to really be done here because see how A is marked as congruent to D. So that's one pair of angles. And then B and E, so that's another pair of angles. So this would be a yes by angle, angle similarity. And then let's see, we have A, C, B, so it's going to be D, F, E. Okay, so that's what the examples look like that you're going to do today for your assignment. Forgot the word there. There are 2 word problems on here that we're probably going to do some word problems next week, so I may as well just show you these 2 examples here. The first one says, to estimate the height of the Jinmao Tower in Shanghai, a tourist sights the top of the tower in a mirror. So you might not know this, but if you say this is you or the tourist, whatever, standing there, if you put a little mirror on the ground and you look in the mirror and say, so here's the tower that they're trying to find I don't know if that's what this tower looks like, but let's pretend. So if they're trying to estimate the height of this tower, you can put a mirror on the ground and either walk towards the mirror or away from the mirror until you see the top of the tower in the mirror. It's called the law of reflection. And so like your eyesight, like the light bounces off the mirror and you can see the top of the tower. So what happens is it creates congruent angles. So these are congruent, these are congruent. So the triangles are similar by angle. So you use that and the given information to figure out what piece is missing. So the tourist is 1.92 meters tall and is standing 0.4 meters from the mirror. The mirror is 87.6 meters from the base of the tower. So obviously I did not draw this to scale, but that's okay. And then how tall is the tower? So we have 2 triangles here that are that are similar. So their sides are proportional. So you can just set up a proportion. So I'm going to do the height of the tower to the height of the person equals the distance to the mirror and over the distance to the mirror. So then you can cross multiply. So we're going to have 0.4x equals 1.92 times 87.6, which is 168.192. And then we can divide that by 0.4. And so the answer here is the tower is approximately 428.48 feet high. Meters, just kidding, meters high. So basically all the application problems with similarity, it's just a scenario that either with a mirror or with shadows, 2 triangles are formed and the triangles are similar. So you just write proportions. They're pretty easy. So this next one says, a person 6 feet tall casts a 1.5 foot long shadow. So this is supposed to represent the person. There's their shadow. At the same time that a flagpole, which we don't know how tall the flagpole is, that's what we're going to try to find, casts a 7 foot long shadow. So picture the sun in the sky hitting these at the same angle. So that's why the triangles are similar, because it's at the same time of day. So this angle, this angle here is congruent to this angle. And then you have the right angles, which represents like where the person's feet hit the ground or where the base of the flagpole hit the ground. And so the triangles are similar by angle. So then you can just set up a proportion. So I can do height of the flagpole to height of the person equals shadow of the flagpole. Whoops, you don't have to put feet in your thing. Shadow of the flagpole to shadow of the person, and then cross multiply. So 1.5x equals 42. And then divide 42 by 1.5, which is 28. And so the height of the flagpole is 28 feet. So your assignment today doesn't have any word problems on it, but I might throw some on Monday, or definitely next week we will do some word problems. Okay, so that's it for today's lesson. Please try the practice and upload it. And if you have any questions at all, please let me know, or you can come for Ad Lab at 1 o'clock. All right, that's it. Have a great day.